So, Nusri, please start the class.
Yes, sir.
I am making you host.
Sir, please make host Rosemont. Oh, I'm already host now.
Oh no, you are the host.
Okay, sir.
So you can change the host position different way.
Okay, okay. Rose, I am making you host, so
Okay,
you can start first.
Okay. So can I start presenting?
Where is Anindita? Anindita not coming.
No, sir, not yet.
Just knock Anindita. Sudhir join. Thank you, Sudhir. Nahana, thank you. Rekha, thank you. Okay, start the class.
Yes, sir.
Okay. Is it visible?
It's coming. Yes, visible.
So welcome to today's class. This is our last class, and the final class was about norm estimation, and we have learned norm estimation by how to find out set score, t-scores, etc. So today we will be moving on to the second part, that is how to find the percentiles and percentile ranks. So this will be our last class. Please attend this. This is a difficult class because you need some time to understand this. So in demonstration, you will be getting more idea. Now just pay attention to the theory class. So first, what we are going to do is we are going to find the percentiles and percentile ranks. So determining percentiles and percentile ranks for values corresponding to the upper and lower limits in a result obtained on a psychological test. So you will be giving a Excel sheet, and you can find the percentiles and percentile ranks after the class. So this Excel sheet is based on a psychological test. That is, we have shown you how we are finding the t-scores and z-scores based on results. In the same way, we are going to show you how to find percentiles and percentile ranks. So what do you mean by a percentile? A percentile means it is used in statistics, and this indicates that it is a value below which given percentage of observations in a group of observations fall. Just take an example that if the 20th percentile is a value or score below which 20% of observations may be found. So this is an example you can consider. I will explain to you after explaining the second one, the term percentile and the related term percentile rank. This is often used in statistics. So what is the connection here? Percentile and percentile rank. For example, if a score is at the 86th percentile, that means where 86 is the percentile rank, it is equal to value below which 86% of the observations may be found. So it is like if the P86 is given as 15. Okay, that means 86th percentile of distribution is 15. This is the this might be confusing, but just just understand in this way that if percentile is given, we have to find the score. If score is given, then we have to find the corresponding percentile rank. So this is what we are explaining here. So just take this example for understanding that if P86 is given, that means the 86th percentile of distribution is 15. So that if percentile rank of score is 15, I think you got confused here. Is it clear? Is it clear? Anyone can respond, please.
Yes, it is clear.
Okay. So no need of more explanation.
No.
Okay, fine. So the 25th percentile is also known as the first quartile, that is Q1, and the 50th percentile as a median or second quartile, that is Q2. And the 75th percentile is considered as the third quartile, that is Q3. You will learn to find the percentile and percentile rank in the demonstration. Just this is an example. That is, this is your data. So here we have this equation to find percentile rank, that is P divided by 100 into n plus 1. That is P is the percentage. So n is equal to the number of scores in the distribution. So in order to find the percentile rank of score 85, what we have to do is the first step is to put the data in ascending order. Then what we'll do is we will divide the number of values below by the total number of values. The total number of values here will be 25. There will be total 25 here. So then in order to find the percentile, what we do is number of values below the score is divided by total number of scores into 100. That is number of values below the score 85. Then here the 14. The number of scores below the value, below the score will be 14. Then there will be 14 scores. Then it will be divided by the total number of scores, that is 25. And it will be multiplied by 100 and we will get 56%. So step 3 is to find the rank. That means the percentile rank. So in order to that, we have a formula, that is P divided by 100 into n plus 1. That is, we have got 56% here. Then we will divide 56 by 100 and multiply it with 25 plus 1. Then we will get 14.56. Is it clear? So this is the rank. Is this one clear? This is just an example. We will see more in the demonstration. You will learn to find it.
Yes.
Okay.
Yes.
Then we will see what is cumulative frequency and cumulative percentage. So what is the importance of this? What is the role of cumulative frequency and cumulative percentage? So in order to determine these percentiles or percentile ranks, the first step is to find number of individuals who are located at or below each point in the distribution. So this can be done with frequency distribution table by counting the number of scores that are in or below each category on the scale. So these resulting values are called as cumulative frequencies. So we will see what is it in this data. That is, this is our data. We can see the cumulative percent frequency here. This will be the percentage. Then the cumulative relative frequency here. Then using this data, we are going to draw the ogive. When we draw the ogive, what we do is we will take this one. I'll show you here. You can see the x-axis. This is the class boundaries. And here you can see the, you will take the cumulative percent frequency on the y-axis. So in order to draw the Agile, this is very important. So first of all, I will tell you what is an Agile. Agile means it is called a cumulative frequency polygon. So it is a type of frequency polygon that shows cumulative frequencies. Cumulative frequency, what it means is it is a sum of all previous frequencies up to the current point. In other words, cumulative percent are added on the graph from left to right. So the Agile graph, what it plots is it plots the cumulative frequency on the y-axis and the class boundaries on the x-axis. So this is an Agile. You can see the class boundaries and the cumulative frequency here. So as I have shown you before, this cumulative percent frequency is shown on the y-axis and this is shown on the x, as you can see in the Agile. So this is just an example. I will show you how with this particular data we can draw the Agile. So this is the Agile of the data. You can see the 0.1, 0.25, 0.5, 0.9. This is the class boundary. And this here we will take the percentage. So how to draw the Agile? So what we are doing is we are marking the x-axis with class boundaries. So the percent cumulative relative frequency on y-axis, we have taken it. Then we are plotting the points. That means each point should be plotted on the upper limit of the class boundary. That means if your first class boundary is 0 to 10, that means the point should be plotted at 10. Okay. You will get an idea when you will do the Agile curve. You will learn how to draw the Agile in the demonstration. Anu, if you want to add something, you can add.
I will add it on in case of demonstration.
Okay.
You can
Okay.
proceed.
Okay. So I hope this is clear, and then we will move on to the demonstration part. Is it clear?
Yes, please.
Okay. Anu, are you doing now? Starting?
Yes, yes. Can you make host?
Yeah. 1 minute. Yes, I have made you post.
Is it visible?
It is coming. Yeah, it is visible. Something is
Yes, I can see the.
there is a screen in front.
It's a black screen. Is it a black screen?
Yeah, it is.
It's happening now.
Is it hanged or something?
I understand it doesn't move. Now is it clear?
Yeah, it is clear. It is clear.
Okay, please let me know, is it visible to all of you, the scores in the Excel sheet?
Please respond. Is it visible to you all?
Yes, it is visible.
Okay.
So here we are taking 20 scores of the 20 individuals. Okay. There are 20 individuals and there are 20 scores of them. And this is the score of the reasoning test, that is a similarity test. Now we will learn how to calculate percentile and percentile rank from the cumulative frequency and from Agile. So for that reason, we have to count what is the maximum number here and what is the minimum number here. And I have already done it. That is, the maximum is 9 and minimum is 3. Okay. Within this range, the maximum score is 9 and minimum score is 3. Now I have to make a class interval for finding out the frequency, cumulative frequency and cumulative percentage. So as the minimum score is 3 and maximum is 9, I have made the class interval like this: 2.5 to 4.5, 4.5 to 6.5, 6.5 to 8.5, and 8.5 to 9.5. So the minimum and the maximum, both of the scores had been covered by this class interval. Is it clear? This is just an assumption. This is just an assuming class interval, nothing else. You can make another class interval like 3 to 5, like this also. Is it clear?
Yes.
Okay. Now I have to count how many scores are there within 2.5 to 4.5, within 4.5 to 6.5, within 6.5 to 8.5, and 8.5 to 10.5. That is the frequency. So for that particular purpose, we can do it with the help of Excel. So I will make a category here. That is like, suppose I will categorize it like 2.5 to 4.5 as 1, 4.5 to 6.5 as 2, 6.5 to 8.5 as 3, 8.5 to 10.5 as 4. So Excel will help you to calculate how many 1 is there, how many 2 is there, how many 3 is there, and how many 4 is there. So for this particular purpose, I will make a category, and the category will be like that. And for making this categorization, I will do the if logical test. That is equal to if the cell B2 less than, what is the upper limit of the first class interval? That is 4.5. So if B2 less than 4.5, comma, put 1. So all the scores within 2.5 to 4.5 will be categorized as 1. So this is the comment for that. If B2 less than 4.5, put 1. Again, I will put if B2 less than, what is our next upper limit? That is 6.5. So B2 less than 6.5, comma 2. That means all the scores within 4.5 to 6.5 will be categorized as 2, comma if B2 less than, the next upper limit is 8.5. So if B2 less than 8.5, put 3, comma if B2 less than 10.5, put 4. So how many command is there? 1, 2, 3, 4. So 4 bracket will be closed. Roll 4 brackets will be there. So we got this one. Now I will drag it down. So I have got all the categorization. Is it clear up to that? Hello?
Nahana is saying yes.
Okay. So now I am proceeding. After this categorization, I have to calculate the frequency. So I have to count how many 1 is there, how many 2 is there. Because the 1 is categorized as 2.5 to 4.5. So I need how many 1 is there. So what I will do equal to count if the range is here to here, C2 to C21, comma 1. The criteria is 1 because I need how many 1 is there, bracket close, enter. So 9. That means there are 9 scores within 2.5 to 4.5 range. Is it clear?
Yes, ma'am.
Okay. Now again I have to calculate the count if the range, that is C2 to C21, C2 to C21, comma 2, bracket close, enter. Eight. That means there are 8 scores within 4.5 to 6.5. Again equal to count if the range C2 to C21, comma 3, bracket close, enter. 2. That means there are 2 scores within the range of, within the class interval of 6.5 to 8.5. Again equal to count if the range, that is C2 to C21, comma 4, bracket close, enter. So there are only 1 score within the class interval of 8.5 to 10.5. Clear up to that?
Yes, ma'am.
Okay. Now I have to calculate the cumulative frequency. So you know the cumulative frequency is the summation of all the frequencies. So 9, and hence it will be 9 plus 8. It will be 17 plus 2, that is 19, and this is 20. 20. So you know what is cumulative frequency, and now I have to calculate the, you can do a sum here so you can understand. Sum of the frequencies. As there are 20 individuals, the sum must be 20. Now I have to do the cumulative percentage. So this is about 9 divided by 20. So this is 45, 17 out of 20, 200, is 85, 19 divided by 20, 200, it is 95%, and it will be obviously 100%. Now I will just put the upper limits here. 4.5, 6.5, 8.5, and 10.5. Okay, I think this is clear to all of you. Clear up to that? Hello?
Yes, it is saying clear.
Okay. Now you know that we can make a Agile by the cumulative frequency distribution, where the x-axis corresponds to the upper limits of the class interval and y-axis corresponds to the cumulative percentage. So now I will make the Agile. So I'm selecting the cumulative percentages. Then I will go to the insert line. Here is my Agile. Now I have to change the x-axis into the upper limits. I will select that x-axis data, right click, select data, edit, selecting the upper limits. Okay. So I got it. Here, the Agile. Agile should start from the origin, but in Excel, it is not possible, I think. So it starts from the first range, that is, you can see here the scores are plotted at 4.5, 6.5, 8.5, and 10.5. These are the upper limits. And for up to the 4.5, there are 45% of the scores are there. So the 45% here. You can see the y-axis, that is here the 45%. So from at the point of 4.5, at the score of the 4.5, there are 45% of the scores. So what will be the percentile rank of this 4.5 score? 45, because 45% of the scores are there below the point 4.5. Clear? Hello?
So, ma'am, you mean to say that 45 is the percentile rank?
45 is the percentile rank of the score 4.5.
4.5, right.
Yes.
Thank you. Yeah.
Okay. So it will be same for 6.5. The percentile rank for the 6.5 would be 85, because the point is here at 85. Okay.
Yes. Yes.
85. So the percentile rank of the score is 6.5. We can also count down, I mean calculate the percentile rank. You can calculate the scores from the percentile rank also. You can calculate the percentile rank from the score, and you can also calculate the scores from the percentile rank. And in vice versa, you can calculate it. If it was given that the which score comprises the 80% of the 80% of the scores below the score 6.5, you can also get it by the calculation that the 80% is here, 80% is here. You have to draw a line from this point to the x-axis. So you will get, it will be below 6.5, I think, because 6.5 is 85. And if it is 80, it will be below 6.5. Is it clear?
Yes, ma'am.
Okay. So for 85% of the cases, at the point of the score of the 6.5, below the score 6.5, there are 85% of the cases are there. 85% of the scores are there. Below 8.5, 95% of the scores are there, and below 10.5, there are 100% of the scores. Clear?
Yes.
Okay. So now you can calculate the percentile and percentile rank from the Agile by drawing the perpendicular line from the x-axis and from the y-axis. When the score is given, you have to check from the x-axis, you have to draw a perpendicular line to the curve, then you have to draw another line that will connect the y-axis. So you will get the what percentage of the cases are there below that point. And also from these percentages, you can get the particular score. Now, is it clear up to that?
Yes.
Okay. Now I will show you how to calculate percentile and percentile rank from the cumulative frequency. Okay. This calculation is here from the Agile, and the next calculation I will show you, that is calculation of the percentile and percentile rank from the cumulative frequency. So first, check at this box, the method of calculating percentile from frequency distribution. Is it visible to you?
Yes, ma'am. It is visible.
Okay. The formula is PP, that is the particular percentile, equal to L, small l, plus Pn minus capital F divided by Fp into small I. So now we have to know what is the PP, what is the L and Pn, and what is the notation of it. So that P equal to the percentage of the distribution wanted. Okay. That means if it is P50, that means we need the score below which 50% of the scores are there. Okay. If P50 is given, or P75 is given, or P86 is given, that means we need the score of the distribution below which the given percentage of the distribution is there. That means if it is P50, that means we need the score below which 50% of the scores are there. If there is P65, that means we need the score below which the 65% of the scores are there. Okay.
Yes, ma'am.
Okay. So here is the formula. The AL is equal to the exact lower limit of class interval upon which PP lies. Okay. The PN, that is equal to the percentage of N to be counted off in order to reach PP. Capital F is equal to sum of all the scores upon intervals below L. And FP is equal to frequency within the interval upon which PP falls. And small I is the length of the class interval. So now I will show you the calculation of P50. We need the score below which 50% of the scores are there in the distribution. Okay. So for P50, we need to count first the PN, that is the percentage of N to be counted off in order to reach PP. That means 50% of the 20 individuals, because there are 20 individuals in our sample. So we need to calculate the PN first. So I'm writing here PN. PN equal to 50% of the 20 individuals. Okay. So what will be the 50% of 20? 10. So it is 10. Now I have to calculate the L, small l. Equal to L is exact lower limit of class interval upon which PP lies. Exact lower limit of the class interval upon which PP lies. That means, which will be that? %50 of the 20 is equal to 10. Okay. That means 10 is there within 17, within the class interval of 4.5 to 6.5. Because up to 4.5, there are 9.
Yes.
And the 50% of the 20 is 10. So 10 is there within the class interval of 4.5 to 6.5. And the lower limit of this class interval is 4.5. So L equal to 4.5. Okay. Clear?
Yes.
Okay. Now we need to know the capital F. What is the capital F? Capital F is the sum of the all scores upon intervals below L. Sum of all scores upon intervals below L. That means below 4.5, the sum of all scores. The sum of all score is 9 here, below 4.5, isn't it? F is equal to sum of the all scores upon intervals below L. Below L, that means below 4.5, there are sum of the scores are 9. Clear?
No, ma'am, please repeat.
Okay. Capital F is equal to sum of the all scores upon intervals below L. So L is here 4.5.
Okay.
So below 4.5, what is the sum of all scores? That is 9 only.
That is, yes, 9.
So capital F is equal to 9. Now we need to know the FP, small fp. That is the frequency within the interval upon which PP falls. Here PP is P50. So P50 is about the 50% of the 20, that is 10. So 10 is here. 10 is here within the class interval of 4.5 to 6.5.
Yes.
So FP will be the frequency of that class interval. That means 8. Okay. FP is equal to frequency within the interval upon which PP falls. 10 falls within 4.5 to 6.5. And the corresponding frequency of this class interval is 8. So FP is equal to 8. Clear?
Yes, ma'am.
So FP equal to 8. And now we need to calculate small I, that is the range of this class interval, that is 3. 4.5 to 6.5, that is 3. Okay. Now we have to just put the formula. So it will be 4.5 plus the Pn is 10. So 10 minus, if capital F is equal to 9. So 10 minus 9 divided by Fp, that is 8. Whole should be multiplied by I, that is 3. Here, is it clear? 4.5 plus 10 minus 9 divided by 8 into 3. There should be a second bracket. Now I think it's clear. Clear?
Yes.
So that is equal to, you can calculate it. Please calculate with me. 4.5 plus 10 minus 9 divided by 8 into 3. So 10 minus 8 divided by 8, that means 1 by 8. 1 by 8, that is 0.125. 0.125 into 3, that is 0.375. Plus 4.5. So the score is 4.875 or 4.87. Clear? Score is 4.87. You can check here from this Agile. Thus, if the score is at the 4.87, that means it is here approximately. If we draw a perpendicular line from this to this, then it became 50. Isn't it?
No, I have shared that picture in the group
Which picture?
about the P50, how to draw the perpendicular.
Okay, okay, okay. So that means below the score 4.87, 50% of the scores are there within this distribution. Is it clear? Below the score 4.87, 50% scores are there within the distribution of the
Yes.
distribution. And you
Yes.
can check it from this ogive also. If the score is here, it will be approximately here because 4.5 is there. 5.5 should be there and 6.5 is there. So 4.87 must be there approximately. And if we draw a line from this x-axis to the curve, it will touches to the 50. That means below the score 4.87, there are 50% of the scores. Clear? Is it clear?
Yes, ma'am.
Okay. Now, another thing is that calculation of the percentile rank from the frequency distribution. This is the method of calculating the percentile from the frequency distribution. That is the finding out the score from the percentile. And now we have the score. We have to find out the percentile rank. Okay. This is a hectic type. This is very easy calculation, but a hectic type of calculation. So please concentrate on it. This is the method. Okay. So method of calculating percentile rank from distribution, frequency distribution. Suppose the score 5 is given. And now the question is, what is the percentile rank of the score 5 in this particular distribution? In this particular distribution, what is the percentile rank of the score 5? Okay. Is this question is clear?
Yes, ma'am.
Okay. Now, if the score is 5, if we try to find out the percentile rank, we have to first note that up to the score 4.5, 45% of the scores are there. Up to the score 4.5, 45% of the scores are there. And up to the score 6.5, from 2.5 to 6.5, 85% of the scores are there. Is it clear to you? Hopefully it's clear.
Yes, ma'am.
Now we need to know what percentage of the scores are there up to the score 5. For that reason, we have to calculate that what percentage of the scores are there between 4.5 to 5. Because up to 4.5, 45% of the scores are there, it is known to us. Up to 6.5, 85% of the scores are there, it is also known to us. We need 5. Up to 5, what percentage of the scores are there? For that particular purpose, we need to calculate the difference. That means what percentage of the scores are there between 4.5 to 5? Isn't it?
Yes.
So for that reason, the step one is to just, this is the noting, I mean the note that is up to the score 4.5, there are 45% of the scores, and up to the score 6.5, there are 85% of the score. The step two is the finding out from the score 4.5 to the score 5, what percentage of the scores are there. So what is the formula? That is distance from 5 to 4.5. Distance from 5 to 4.5 divided by units of class interval where the score 5 lies into score 4.5 to 6.5 correspond to 85% to 45%. Okay, now let me explain. First, the distance from the 5 to 4.5. What is the distance from the 5 to 4.5? That is 5 minus 4.5. So it will be 0.5. Clear?
Yes, ma'am.
Okay. Now divided by units of class interval where the score 5 lies. Where the score 5 lies? Score 5 lies within this interval, isn't it?
Yes.
So units of class interval means 6.5 minus 4.5, that is 2. Okay. Clear. Units of the class intervals where the score 5 lies, that is the class interval, that is the 2 units are there. So it will be 2 into the score, the percentage of the score correspond to 4.5 to 6.5 into percentage of the score correspond to 4.5 to 6.5. That means 85% minus 45%. Is it clear or may I have to repeat it?
Clear, ma'am.
Okay. So that will be 0.5 divided by 2 into 40. Why we need the percentage of the scores that is within 4.5 to 6.5? Up to 4.5, there is 45% of the scores. Up to 6.5, there are 85% of scores. So within the 4.5 to 6.5, there should be 85 minus 45% of the scores. Here?
Yes, clear, ma'am.
Okay. So this is the 0.5 divided by 2 into 40 equal to 10. So from the score 4.5 to the score 5, there are 10% of the scores that we got from this formula. From the score 4.5 to the score 5, there are 10% of the scores are there. Now we need up to 5, what percentage of the scores are there? So up to 4.5, there are 45%. And from 4.5 to 5, there are 10%. So up to 5, that should be 45 plus 10%. 45% plus 10%, that is 55%. Clear? If it is not clear, please ask me.
No, please repeat once.
Okay. First, from the first, I'm repeating it for your better understanding. So, we need to calculate the percentile rank of the score 5. That means what percentage of the scores are there below the score 5? That is our question. For that purpose, first we have to note that up to the score 4.5, there are 45% of the scores. And up to the score 6.5, there are 85% of the scores. Now we need to know from 4.5 to 5, what percentage of the scores are there? Because from this frequency distribution, we can calculate up to 4.5, up to 6.5, up to 8.5, up to 10.5. But if any score is there in between, we have to calculate the distance between them. So we know that up to 4.5, there are 45% of the scores. Up to 6.5, there are 85% of the scores. Now we need to know from 4.5 to 5, what percentage of the scores are there? Okay. For that reason, we are putting into the formula, that is the distance from 5 to 4.5 divided by units of class interval where the score 5 lies into the score. Okay, let me rewrite it. Score, the percentage of the scores. Percentage of the score correspond to 4.5 to 6.5. Now I think it's clear. Distance from 5 to 4.5 divided by units of class interval where the score 5 lies into percentage of the score correspond to 4.5 to 6.5. That means we need the percentage of the scores that correspond to the 4.5 to 6.5. So how can we get it? We know that is up to 4.5, there are 45%, up to 6.5, there are 85%. So within the 4.5 to 6.5, that should be 85 minus 45. Is it clear? Up to 6.5 up to 6.5, that indicates from 2.5 to 6.5, isn't it?
Yes, yes.
So if from 2.5 to 6.5 it is 85, and from 2.45 to 4.5 it is 45. So from 4.5 to 5, so I mean 4.5 to 6.5, it should be 85 minus 45.
Yes.
That is the thing here. The percentage of the score that correspond to 4.5 to 6.5, that is 85% minus 45% of the distribution. Here.
Clear, ma'am.
So here is the formula 0.5, that is the distance from 5 to 4.5, that is 5 minus 4.5, that is 0.5 divided by units of the class interval where the score 5 lies, that is 2. Class interval, that is the 2. Units of class interval, that is 2, into 40. 85 minus 45, that is 40. So that is equal to 1. Sorry, 10. That means from the score 4.5 to the score 5, there are 10% of the scores here.
Yes.
Okay. Now we need to know up to 5, what percentage of the scores are there. So up to 4.5, there are 45% of the scores. From 4.5 to 5, there are 10% of the scores. So up to 5, that should be 45% plus 10%, that is 55% of the scores. Clear?
Yes, ma'am.
Okay. So this is 55. That means the percentile rank of the score 5 is 55. That means below the score 5, there are 55% of the scores in this particular distribution. Clear?
Yes, ma'am.
Okay. So it's over. I think all of you have understood it. Now we will give you an assignment and you have to calculate. The assignment is about the P75 and P85 that will be given you later. So if there is any doubt, please tell me. Anyone? If there is no doubt, then I will stop sharing. May I stop?
Yes, ma'am. No doubt.
Okay, thank you. Rose, do you want to say anything?
No. Actually, this is the last class. So thank you for joining in the classes. I know some of you might have missed some classes.
Yes. So this is to say you that the examination is on 20th March and 27th March is the last date of the submission of the all assignments. So please do complete it and please appear for the final examination. Otherwise, the course completion certificates will not be given to you. Okay, so good wishes. This is the last class today. If you have any doubt, any one of you, then you can ask questions in the WhatsApp group in between.
Or if you want to say something about the course or the class, you can share it now. Can anyone say feedback about the classes?
Ma'am, all the classes, they were wonderful, and personally, I learned a lot, and all the coordinators and teachers, they worked diligently to teach us. And overall, I can say it was a wonderful course. I have learned so many things. Things now they are more clear, and we have learned more before that. Thank you.
Thank you so much, Rani. Okay, I think nothing to be discussed now. We can stop it.
Yeah.
Okay, good night.
Night. Thank you.
Okay, thank you, ma'am.
Most welcome.